So Peyton, you may have already gotten this example when the picture that you took, I'm not sure, but we we just set up the example yesterday.
Okay.
All right, so when stopping people for suspected DUI, 78% of the suspected drivers get a breath test, 36 a blood test, and 22 get both. And so we wrote down this table. So something to note is that the 78% and 36% are totals. If you remember, that's called a marginal distribution. It's like the totals for each category kind of thing. Back from chapter 3. 22% is a joint distribution. So I'm going to go ahead and set up a little Venn diagram over here. So we're going to do blood, breath, and then this middle region is going to be both. So we know the joint distribution that get both is 22%, so 0.22 is going in this middle region here. Kind of hard to see, but there it is. Then for breath and blood, remember we have to subtract off from the total that got a breath test. We have to subtract off that 22%, okay? So we're going to do 0.78 minus 0.22, which is going to be 0.56. So all that means is that 56% just got a breath test. Then we do the same thing for blood, except for this one is 0.36, the total that got a blood test, minus the ones that got both, minus 0.22 is 0.14. So 14% only got a blood test, is what that says. So now I can use this information to also help fill in my table because it's what I'm trying to do. So, let's see. Breath test but no blood test was 0.56. So 0.56 goes here. Blood test but no breath test is the 0.14. So now, how many people didn't get either? Or are there any that didn't get either?
There are some. Wait. 8%. 0.22. Wait. 0.08. I guess.
Okay, so 0.08 got neither. So 0.08 goes here. They didn't get a blood test or a breath test. Okay, so we had to add up what's inside the Venn diagram. 0.14 plus 0.22 plus 0.56. And then subtract that from 1, and we were left with 0.08. They got neither. And then we just need to add up these totals that I haven't found yet. So this was going to be 0.12. And then this is going to be...
Yeah.
Sorry. Yep. Thanks.
It was kind of
I was adding up just the 4 and the 8. That's where that. Why I did that. Okay, then this one. I would have realized it when I said we need to check our totals and make sure that they add up to 1.
0.64.
Thanks. So then we always add up the totals to make sure that they are equal to 1. So this is equal to 1, this is equal to 1, and then we're good. Huh?
That would be
All right, replacement and without replacement. So, be aware of conditional probabilities. Due to non-replacement of possible outcomes. Think it through. Okay, so basically replacement versus without replacement. It's like if we had a bag of marbles, or maybe you've watched the, like that game on The Price is Right where it's the 3 strikes game where they have the numbers for like the car or whatever in there, and then they have 3 strikes in there. The numbers, when you take them out and you get it right, they don't get put back in, right? So that one they go like they insert in the machine or whatever. But the X's, I can't remember the last time I watched it, but they put those back in, I think. Maybe not. I don't remember. Anyways, I'm pretty sure they put them back in. So you could theoretically keep pulling X's, okay? Because they're going to keep, and obviously there's 3 of them in there. So your odds get higher the more numbers you actually pull because of that. But like with marbles, if we had 5 red marbles, 4 blue marbles, and we take 1 out, you know, if we leave it out, then the percentage of pulling either the blue or the red will change based on if we took it out, because the number total left in the bag is different. But if we put it back in, the percentage stays the same every time. So that's why we have to be careful about that. But something that can help is diagramming. Because tree diagrams show sequences of events it helps us reason through the situation and calculate complicated probabilities. All right, Peyton, you probably don't have this next page. It's like one long example, so you can either write it or take a picture after if you want everything to be in order. I don't really care. All right, so this example, 44% of students binge drink means that they drink a lot of root beer. Huh?
What kind of students are these?
College?
Students? I don't know.
It's college.
Well, in a minute you'll find out that at least that some of them have been in accidents, so they at least have to be driving.
That's
Wow.
still
not
So-
comforting though.
37% drink root beer moderately.
Oh, root beer?
No, I'm joking.
Oh. That's what, for the video we gotta. It was not safe for kids.
18 plus.
Don't let Mr. Law watch these stats videos because he'll come and change the curriculum or something.
Except for we can't because it's AP.
So,
19% abstain, meaning they don't drink at all.
Only 19%. That's kind of sad.
I love
That's not the same
abstinence.
What?
Nothing.
Which,
I said abstinence and I was like, wait, no, that's not the same.
oh no, that is not the same thing.
All right, and then the other piece of information they give us is that among binge drinkers, 17% have been in an alcohol related accident. But among non-binge drinkers, only 9% have been in, I'm not going to write it, but have been in an alcohol-related accident. Ditto to the rest of that previous statement.
Yeah.
Well, we know the 9% cannot be from the ones who abstain. Wait, that's not true.
9% would be non-binge drinkers, so that would be abstain or
Or
drink moderately.
Hey, you're still.
I was gonna say they don't
drinking
drink, so it
anyway.
can't be their fault, but they can be in a car with somebody who
Yeah.
doesn't drink. So,
I've never been in a car.
never seen
Actually, never mind. They are saying non-binge are only the moderate. So basically, the ones who drink moderately are 9%. That is what that means.
Oh, they're not saying.
Yeah,
staying
no,
at
they,
all.
yeah.
that.
Oh, okay.
Because, like you said, because I was thinking it just said accident, but because it says alcohol related, it would have to
that
be,
makes sense.
yeah.
Okay, so it can only be the one.
Yeah. That's why I was thinking it just said has been in an accident, but then, yeah. Anyways, that would be a whole other realm of things. All right, so we're going to do a tree diagram, but I'm going to write a little bit about the tree diagram first before I actually draw it. All right, the first branch separates by type of drinker. So basically, I'm going to have 3 branches coming off initially. Okay? I'm going to have binge drinker, moderate, or abstain is going to be my first one.
Right.
All possible outcomes will total up to 1. Okay, so all these added together would be equal to 1. I think, I hope. It's supposed to. Then, when we add accidents, these numbers depend on drinking behavior. But if 17% have been in an alcohol-related accident, what do we know? How many have not? So 83% have not. So those numbers are still going to total up to 1 within that next branching of things.
Okay.
So I'm going to come down here so that I can appropriately draw out my situation. That's kind of big. All right, so I'm gonna have binge drinkers. What?
So it's like the beak of a bird.
I was thinking the foot of a bird.
Oh.
Also.
I was thinking
I think it's beat.
You're thinking what? I thought you said triangle.
All right, so each of these little branches, okay, equates to one of the possible situations. Okay, and we're going to put the percentage underneath as a decimal. So binge was 0.44, moderate is 0.37, and abstain was 0.19. You're not welcome.
Must already started.
They probably don't.
Sideways. Yeah, it is.
That's not what I'm saying.
Really? Oh, y'all aren't creative.
I'm seeing tree roots.
Well,
think
y'all
that's the
aren't
goal.
creative.
Maybe you're just.
I was that kid with that, like, when I looked at the clouds, people would, like, see the shapes. I would think of, like, the most abstract thing. They'd be like, how did what? What?
It's like the people who put the art in the middle of Warwick Boulevard.
Oh my gosh.
The what?
The art that's in the middle of Warwick Boulevard.
I
Like,
just-
don't- Yeah, there's actually a couple of them.
Yeah, it's interesting.
All right, so then these branches are going to be if they got into an accident or not. So I'm just going to do like ACC for accident or no for no accident. Now we said 17% were in an alcohol-related accident if they were a binge drinker, so it's going to be 0.17. So then the ones that did not is 0.83. Moderate accident was 0.09. No accident then would be 0.91. If they didn't drink, they can't possibly be in an alcohol-related accident, so 0 and 1. So then just something about this. Each branch
Ew, to you too.
represents a condition multiply across the whole branch to calculate so I'm going to be multiplying 0.44 times 0.17, which is going to be 0.075, 0.44 times 0.83, 0.365, 0.37 times 0.09 is 0.033, 0.37 times 0.91 is 0.337, 0.19 times 0 is 0, and 0.19 times 1 is 0.19. I'm just that
You already
good.
have those answers.
No, I just did them in my head. Yes, I already had them.
I was about to say.
Nathan is.
She was like, how is she doing it? So
I did come to
Alright, so then some questions we can answer from this. What is the probability that they're a binge drinker and they get in an accident?
Point oh seven five.
Or wait.
Yeah. Now, I'm going to write this in the form that we got. I don't remember if it was yesterday or the day before, but I guess the day before. So the probability of binge times the probability of an accident given that they binge. Okay, that's just another way we can write that formula, which is 0.44 times 0.17. Change colors. So by doing this tree diagram, I was already able to get that number without actually really having to show work per se.
Oh, I see.
That's nice. I feel like
that's
it took me
nice.
forever to like read that though.
It did not take so.
It really.
Well, that's what I said. I feel like I would.
That was hard.
What?
Let's untangle the ties.
Oh my god.
All right, the probability of an accident, though, okay, this is where we add up all the probabilities of an accident. So this is going to be 0.075
The notes, so I'll have to go out of order.
Oh.
plus 0.033 plus 0 is 0.108. So we just add all three. They are joint probabilities. Now we're going to look at a conditional probability that we don't already have the answer to. The probability that they binge given that they have been in an accident. So remember what this means is the probability that they binge intersected with an accident, so that they have had both, basically. Divided by, it's always the probability of the second thing, the probability of an accident. And what do you know? We can use the two things we just found.
Whoa. It's almost like it was done on purpose.
Wow.
0.075 divided by 0.108 is equal to 0.694.
Huh?
This question.
All right, so tomorrow for real, we're going to do those worksheets
For real.
Okay.
and look at lots of probabilities. Make sure you know lots of things about decks of cards, which y'all already seem to know, which is good.